So let us discuss this example. In this example, we have a function, okay, which is a vector field since it is a function from R2 to R2, and we have to prove that it is continuous at 0, 0. Okay, so what will we do? Actually, it has a two component functions. F1, we will call it as F1 and F2. So first we will prove that F1 is continuous at 0, 0, and after that we will prove that F2 is continuous at 0, 0. So as you know the result, that means if each component function is continuous at any particular point, then the given vector field is also continuous at that point. So let us start to do. So first of all, I will write the given function. We have, what is the function we have? F of x is equal to cos x plus y comma sin x minus y. Okay, so actually it has a two component function. So here, what is the first component function? F1 of xy is equal to cos x plus y, and second component function F2 of xy is equal to sin x minus y. So first of all, we will prove that F1 is continuous at 0, 0. So now we will prove that F1 is continuous at 0, 0. Okay. So as you know the definition of continuous function, epsilon delta definition. So first of all, I will take one epsilon, and for that epsilon we have to find a suitable delta. Okay. So let epsilon greater than 0 be given. Okay. So I will clearly mention we have to find a delta which will satisfy the definition. So we write we have to find delta greater than 0 such that I will write here, I will clearly mention all these things, such that norm xy minus 0, 0 less than delta implies mod f1 of xy minus f1 of 0, 0 less than epsilon. Okay, see, keep in mind one thing. So we have a vector field f, okay, but it has two components, f1 and f2. These are not vector fields. F1 and f2 are scalar fields. So that's why we have to take mod here. Getting if we have a vector field, then we have to take norm. But f1 and f2 are scalar fields, so that's why I'm taking mod here. Okay. So for this epsilon, we have to find delta, which will satisfy this definition. Okay. So let us start to solve this problem by considering this mod. We will find its value, and after that we will go further. So let us consider mod f1 of xy minus f1 of 0, 0. What is my f1 of xy? It is cos x plus y. So it is cos x plus y minus f1 of 0, 0. So here I have to put 0. So it is cos 0, and here y 0. So that's why 0. So this is equal to mod cos x plus y. Cos 0 is 1, 0 is 0. So I will make a pair cos x minus 1 plus y. I simply interchange them, right? So see, I can take separate mod. If I take separate mod, value will get increased. Mod cos x minus 1 plus mod y. So as you know, mod a minus b is same as mod b minus a. So that's why you can interchange. So this is mod 1 minus cos x plus mod y, right? Okay, so this thing we have got, we have to solve it further, but yeah, no space we have. So make a screenshot of it, and after that we will go for remaining part of this problem. Okay. Okay, so let us continue. I will simply continue. So this is equal to, do you know the formula of 1 minus cos theta? It is 2 sine square theta by 2. So this formula we have, 1 minus cos theta is equal to 2 sine square theta by 2. So I am going to apply this formula here. So this is 2 sine square x by 2 plus mod y. Okay, remove it now. See, but there is very important thing, that is mod sine theta is less than or equal to mod theta for small value of theta. Okay, small value of theta. So therefore, see, what can I write here? Therefore I can write, so this is less than or equal to its constants, and it is positive, so it will come outside the mod. Okay, and see, sine x by 2, so sine theta is less than or equal to theta, so I can write this is mod x by 2, but see, it has a square, so I should write square. So sine theta is less than or equal to theta, but there is square, so I wrote square here, plus mod y. So let us simplify it. So this is equal to, what will happen, this is 2x square, getting, so x square by 4 plus mod y. So actually there is no need to consider mod, okay, since square is there and it cannot be negative, so there is no need to consider mod. So this is equal to 2 will get cancelled, and we will have x square by 2 plus mod y. Okay, so this thing we have, or simply we can write, see, x square, okay, we will keep as it is. Okay, keep as it is. So therefore what will I conclude? Therefore we started with mod f1 of xy minus f1 of 0 0. We started with this one, and what we have got, this is somewhere less than or equal to x square by 2 plus mod y. I will call it inequality number 1. Okay, this thing we have got, and this thing we have solved. So after that, now we have to select a particular delta. Now we choose delta is equal to, but really we don't know which delta we have to select, so we will keep it blank and we will go further. After solving few steps, we will come to know the required value of delta. Okay, so I will remove it and let us continue. So let us continue. I don't know the value of delta, so consider, now I consider norm xy minus 0 0 less than delta, and what we supposed to get, we should have mod f1 of xy minus f1 of 0 0 should be less than epsilon. Their definition will satisfy, and we can say f1 is continuous at 0 0. So let us solve this one. What can we do here? See, do you know how to do subtraction, component wise subtraction? X minus 0 x, y minus 0 y. So we'll have norm xy less than delta. Implies, you know how to find norm, square root of. Okay, so it's square root of x square plus y square less than delta. I think you can easily guess the next step. We have to remove square root by taking square of both sides. So this is x square plus y square less than delta square. Next step, we will consider that means this one, sum of these two positive numbers is less than delta square, so each of them is also less than delta square. So that's why I can write x square less than delta square and y square less than delta square. Implies x square less than delta square and mod y less than delta. What I have done, see, I have taken square root of both sides of this term only. I didn't take off this term because x square we have, getting, so x square we have, so that's why x square is less than delta square, and mod y is there, so that's why I take just square root of this part only. Okay, so I hope all of you understood up to this step. So make a screenshot of it, and after that we will go for remaining part of this problem. Okay, so I have kept as it is, so you can see here when we solve the problem. So then one becomes, see what will happen, one becomes mod f1 of xy minus f1 of 0 0, okay, less than or equal to x square by 2 plus mod y, right? So see, x square is less than delta square, so I can write this is less than delta square by 2, and what we have, mod y is less than delta, so this is less than delta. Getting? So can you tell me the value of delta? Cannot say directly, we have to prove that this is less than epsilon. So what will I do? I'm going to do one adjustment. Okay, so that is delta is equal to minimum of 1 and some another term. I don't know the second term, but here I am considering delta should be minimum of 1 and 2. So what will happen? See here, what will happen because of that? So this is equal to delta square means what? Delta by 2 into delta plus delta. Getting my point? Delta into delta, delta square we will have. See, I will keep delta by 2 as it is. Simply, what will I do? See, this delta is minimum of 1 and c. So that means delta is either equal to 1 or less than 1. Okay, so that's why I can write this is less than delta by 2 into 1 plus delta. Getting the point? So since delta is minimum of these two, so delta should be less than or equal to 1. Less than or equal to 1. Correct? See, delta by 2 into 1, delta by 2 plus delta. That means if you cross multiply it is 3 delta by 2. But we want epsilon there. So what will I take? I will take 2 epsilon by 3. My choice of delta should be minimum of 1 and 2 epsilon by 3. So because of that, this is less than or equal to 3 by 2. Delta is less than or equal to 1 and less than or equal to 2 epsilon by 3. So 2 epsilon by 3. So 3 will get cancelled, 2 will get cancelled, and what will we have? Epsilon. So finally we got epsilon there. So in this way we proved this one is less than or equal less than epsilon. Okay. So just make a screenshot of it. I will remove this part and then we will go further. Please. Okay, so let us continue. So therefore, what can I say? Therefore, we started with what? Norm xy minus 0, 0 less than delta implies mod f1 of xy minus f1 of 0, 0 less than, less than what we have proved, it is less than epsilon. So the definition is satisfied. So that's why we can declare f1 is continuous at 0, 0. So therefore f1 is continuous at 0, 0. See, now we have to prove. Now we have proved f1 is continuous. So now we will focus on f2 and we will prove that f2 is also continuous at 0, 0. Now we will prove that f2 is continuous at 0, 0. We'll prove f2 is continuous at 0, 0. Okay. So again we have to do the same thing. We have to take one epsilon, and for that epsilon we have to find delta. So see, let epsilon greater than 0 be given, and I will clearly mention for this epsilon we have to find delta. We have to find delta greater than 0 such that simply it should follow the definition such that norm xy minus 0, 0 less than delta implies mod f2 of xy minus f2 of 0, 0 should be less than epsilon. Okay, so for this epsilon we have to find delta which will satisfy the definition. Okay, we will focus on this one. We will try to find the value of that mod, but before that make a screenshot of it and then we will go further. Okay, so let us consider that mod. So consider what we have to consider, that mod f2 of xy minus f2 of 0, 0. Okay, so let us solve it. What is f2 of xy? This is our f2, getting second component, sin x minus y. So this is equal to mod sin x minus y. f2 of 0, 0, that means we have to put x is equal to 0, y is equal to 0. If I put 0 here, what is value of sin 0? It's 0. So minus 0, and y is also 0. So we will have simply mod sin x minus y. If we take separate mod value, possibly we get increase. So this is less than or equal to mod sin x plus mod y. Okay, so do you know that mod sin theta is less than or equal to theta for a small value of theta? I think already I have told you. Okay, see, so this is less than or equal to mod x plus mod y. I can clearly mention because mod of sin theta less than or equal to mod theta for small value of theta. Okay, for small value of theta. Okay, so let us continue. Okay, so see, after that we have to select, I will call it as inequality number 2. After that we have to select a delta. So let delta is equal to, but see here really we don't know the value of delta. No problem, we will keep it blank and we will go further. Okay, so let us consider now. So consider norm xy minus 0 0 less than delta. We will consider this thing and we have to prove that this mod should be less than epsilon. Okay, but before that let us simplify it. You know well how to subtract, component wise subtraction, x minus 0 0, y minus 0 0, sorry, x minus 0 x and y minus 0 y. So here xy less than delta, right? So how to find norm? By taking square root. So this is square root of x square plus y square less than delta. Guess the next step? Yes, we will remove square root by taking square of both sides. So implies x square plus y square less than delta square. I'm sure you're familiar with this step. So after that, sum of these two positive numbers is less than delta square. So that's why each of them is less than delta square. So this is x square less than delta square and y square less than delta square. Okay, so see, after that we'll take square root of both sides. So mod x less than delta and mod y less than delta. So after that, yeah, here, okay, before that I will write then from 2 becomes, or directly I can write 2 becomes. So what we get, 2 becomes mod, okay, mod f2 of xy, mod f2 of xy minus f2 of 0 0. So already we have proved it is less than or equal to mod x plus mod y, right? But mod x is less than delta, mod y is also less than delta. So delta plus delta, it is 2 delta. We had to prove that it is less than epsilon. So my choice of delta should be epsilon by 2. So this is equal to 2 epsilon by 2. 2 to cancel and we will have epsilon. So in this way we proved that its mod is less than epsilon. Okay. So the definition is satisfied now. So simply we need to mention all these things there. So before that, make a screenshot of it, please. Okay, so now we will simply mention which we have got. Okay, so therefore what we get here, therefore we get, see, we started with norm xy minus 0 0 less than delta, sorry, here this is less than delta, implies mod f2 of xy minus f2 of 0 0, we got it is less than epsilon. So therefore we can declare, so therefore f2 is continuous at 0 0. Okay, so first we proved f1 is continuous at 0 0. Now we are saying f2 is continuous at 0 0. Therefore each component function, okay, so therefore each component function of f is continuous at 0 0. So therefore we can declare f is also continuous at 0 0. So therefore f is continuous at 0 0. So in this way we completed this example. Make a screenshot of it and after that we will stop. Thank you. Bye bye.